You are watching the paint problem help video. In this video, I'm going to show you how to solve the paint problem, but I'm not going to use the exact same layout that you were given in class. I'm going to use this diagram that's in front of you. When I solve this problem, I'm also going to change up some of the parameters on as far as the numbers that I gave you, because I want you to actually work through this problem using what you learned from this video and not copy anything that I do word for word. So the first thing that we need to do in order to solve the paint problem is we need to figure out how much wall needs to be painted. On your drawing, there are some blacked out sections that represent the windows, kind of like my black bars on this image in front of you. And there's also some black spots to represent where the counter and the cabinets are in my classroom. So the first job is to figure out, all right, well, how much of the white paintable area is left over after we eliminate the black bars? So the first thing that we're going to do is break out our ruler, and we're going to measure in centimeters, not inches. We're going to measure in centimeters all of the different lengths of both the entire square, the entire space, and all of the edges of the black shapes. In order to do that, I'm going to put on my drawing, I'm going to write in blue all of my measurements for the actual drawing. Now that I've got all my measurements put down on my drawing, the next step of this is to multiply all of these measurements on the drawing by 40 in order to get the amount of distance that we have on the actual wall. On the paper that you have assigned from class for the paint problem, you should see the warning there on the paper that says if you were to find the area of this entire drawing first and then scale it up to the appropriate size for the wall, if you multiply your area by 40, because you're dealing in square centimeters at that point, because a centimeter times a centimeter when you're doing length times width, your units then become square centimeters, and you can't simply just multiply that by 40 in order to get the right scale. So we have to multiply all of our measurements on paper by 40 to get the size on the wall. I'm going to do those measurements in red. So there are all the measurements for the actual wall. Like again, I just said, I just multiplied all these measurements by 40 in order to get the actual measurements for the wall. Now, our next step is to figure out how much paintable area do we have. And you could go about this a couple of different ways, but I think that the easiest way is to figure out what is the area of this entire box, even with the black squares inside of it. What's the area of the entire box, and then subtract the black squares from that total area in order to get what we need. So here is the math when I do that. So my total area was the 700 centimeters by 500 centimeters, and that comes out to 350,000, length times width. And then for my black boxes, it just so happens that I've got two black boxes that are identical, so I'm going to do 120 times 340, and then multiply that by the two boxes, and I end up with 81,600. So my total area that I need to paint is 268,400 centimeters squared. So my unit changes from centimeters, if I'm just doing one length or a width, to centimeters squared because I multiplied centimeters by centimeters. So it says in the paint problem that we're actually going to do this, or paint this wall twice. So I need to multiply that by 2. So I'm going to take my 268 times 2, because I have to do 2 coats. And when I do that, it shows that on my calculator that I'm going to have to paint 536,800 square centimeters of total wall since I'm doing it twice. So what I'm going to do is I'm going to clean up my workspace a little bit here. So I'm going to keep that 536,800, and that's one of my givens now. And actually that's the number that I'm going to start with here in just a second. And then we're also going to list out all the things that are given to us in the problem itself. So let me clean up my space. And I'm going to just start listing the things that I know. So I know that I have 536,800 square centimeters of wall that I need to paint. I also know, according to my handout, that my paint, remember I'm using a different paint than what's on your handout, my paint covers 36.8 square meters of wall for every, let's see, my handout says for every gallon, for 1 gallon. It also says in my handout that paint costs, let's see, my handout says paint costs $6.75, that's in dollars, for every quart. So these are all the pieces of information that I've given. Now, there are a lot of different ways that you can solve a dimensional analysis problem, and that's kind of one of the nice things about math, is there's more than one way to do anything. But I've always done dimensional analysis kind of the same way, and if you are stumped for how to do these two, I highly recommend you adopt my way. So what I do first is I write over on the far right side of my paper the unit that I'm shooting for. So the paint problem is asking me to solve for money, and that's a unit, so dollars. And then on the far left side, I always start with one of my givens. So I've got three things that I'm given. I've got this one, I know it's 36.8 square meters for a gallon. I know that it is $6.75 for every 1 quart. And I also know that I have to paint this much wall, 536,800 square centimeters. Oops. So the question always comes up, well, which one do I pick first? Which one do I start with? And the truth is you could start with any one. You can start with either this 36.8 over a gallon or anything. But I find that it's way, way easier that whenever you're given something that doesn't come in a fraction, so this 536,800 centimeters squared, if I start with that, I find that my life is a little easier because I'm only dealing with one unit at a time. So I'm going to start with that one, 536,800 centimeters squared. And we have to turn this into a fraction to do dimensional analysis. So if I put that over a 1, I didn't change the value of this. It's still the same amount. So in dimensional analysis, we've got to do some multiplying because multiplying helps us to get rid of units. And so we've got centimeters squared on the top. We need to get rid of that. And as I look at my two other given pieces of information, I notice that neither one of these things has centimeters squared in it. But I do see that there's a meters squared, which is also a unit of area, which centimeters squared is. So I need another conversion in order to get this meters squared out of there. So I'm going to go to my handy conversion sheet from class, and I see that in the area category of my conversion sheet, it gives me a conversion. So it says 1 meter squared is the same as 10,000 centimeters squared. So that's a conversion I can use. So centimeters squared. All right, so I've just gone to my conversion sheet to add another given, sort of. So now I can convert this thing. So I can get rid of my centimeters squared. And the way that it works with fractions, if you don't remember from math class, is that in order to get rid of something on the top by multiplying, that same something has to be on the bottom of the thing you're multiplying by. So the way that I wrote down this conversion with 1 meter squared per 10,000, that's actually in the right format, so I don't have to flip it. So we put 10,000 on the bottom, centimeters squared, over, and 1 meter squared is on the top. So good. So centimeters squared just canceled out. Now we're left with meters squared. We're still not quite at dollars, so we have to keep going. So now we've got meters squared, and we're looking over our units, and now, hey, look, there's the one we can use because it has meters squared in it, and it's going to bring us to gallons. So we've got a problem, though. So we've got meters squared in the top of our ratio that was given to us, and we also have it on the top of our problem that we're working. Well, the thing that's nice about these ratios is that if I flip this upside down so that I change the denominator to be on the numerator and the numerator to be on the denominator, I'm not changing the value of this because this ratio is saying there's 36.8 meters squared for every gallon. That's how much a gallon of paint can cover. Well, if I flip this around and I say 1 gallon of paint can cover 36.8 meters squared of wall, it's saying the same thing just in the opposite direction. So I can flip that and the math is still good. So I'm going to put 1 gallon on the top, gallon, and 36.8 meters squared on the bottom. Now our meters squared cancel. We're left with gallons. We're almost done. So we've used this conversion. We've used this conversion. We've now got gallons and quarts. So we're going to have to go back to our conversion sheet, and we're going to be looking in the volume section. And it looks like 1 gallon is the same as 4 quarts. So I'm going to grab my green one. So we've got a new conversion. So we've got 4 quarts is the same as 1 gallon. Just took that straight off the conversion sheet. And now we can keep going. So we've got 4 quarts on the top, 1 gallon on the bottom. Now our gallons cancel out, and we're left with quarts. Perfect. We've got a conversion for that. And it is even in the right format with quarts on the bottom. So we've got 675 over 1 quart, and that's of course $675 So we are now ready to solve. Now the next biggest mistake that I see people make is that they forget that you have to do the entire top of this fraction and the entire bottom of this fraction separate. So I'm not totally home free yet, so I need to multiply all the top numbers, 536,800 by 1, by 1, by 4, by 6.5, and all of the denominators. So I'm going to do that real fast. And this is what I get. I get this giant obnoxious number over this not so giant but still obnoxious number. So now we have to divide these two things, and we're going to end up with our dollar amount, and we get $39.38 for our grand total of how much it's going to cost to paint my fictitious wall with my fictitious paint. If you are still struggling with how to solve this problem, please send me an email and come and see me soon. Good luck.